Next, some objective bits related to calculation of radius, density and contributions. So coming to first one. In a closed packet lattice containing n particles, the number of tetrahedral and octahedral voids respectively. So here number of particles are n. Okay. So in that lattice number of atoms or number of particles are n. You know that number of tetrahedral voids are double than that of the number of atoms present in it. And number of octahedral voids are equal to the number of atoms present in it. Why? Because there is a possibility for the formation of tetrahedral voids in two ways. Why? Because tetrahedral void is formed by a set of three spheres belongs to a particular layer and a sphere belongs to above or below the layer. So, upper or lower layer. So, two ways of formation are there. That's why number of tetrahedral voids are always double than the number of atoms which are present in the crystal lattice. Whereas octahedral voids, that is equal to the number of atoms present in the crystal lattice. Why? Because octahedral voids are formed by 6 spheres. 3 spheres belongs to a particular layer and 3 spheres belongs to next layer. That's all. Okay, only one way for the formation of octahedral voids. That's why number of tetrahedral voids are 2n and number of octahedral voids are n. Okay, next, density of a crystal is given by, okay, so formula, density formula, a cube into m by z into n naught into m by z into a cube, zm by a cube into n naught and a cube into n naught by zm. So density of a unit cell, that is calculated from the number of particles present in the unit cell and also edge length. Okay. So number of particles, that is indicated with the symbol Z. Okay. So for different unit cells, simple cube, Z is equal to 1 and BCC, Z is equal to 2, FCC, Z is equal to 4. Okay. So from this number of particles and edge length, we can calculate the density. So density D is equal to Z into m by a cube into n naught, where Z is number of particles, m is atomic mass, a cube is volume of the unit cell, n naught is Avogadro's number. Okay, we can write the same formula as Zm by V into n naught. Okay, so this is another form. Next, edge length of a cube is 400 picometers. Okay, its body diagonal would be, okay, so you have to calculate the body diagonal. So to calculate body diagonal, formula is 4r is equal to root 3 into a. Okay, so here edge length is given, edge length A is given. Okay, A is 400 picometers. So body diagonal, that is also in picometers. So we can substitute the edge length value directly here. Okay, so 4r is edge length. Okay, so this is equal to root 3 value 1.732 into what is edge length value 400. Okay, so this is equal to 693 picometers. Okay, so 693 picometers. Next, in an ionic compound A plus X minus, the radii of A plus and X minus are 1 picometer and 2 picometer respectively. The volume of the unit cell of crystal AX will be, you have to find out the volume. Okay, so you know about the edge length. Edge length is equal to A. Okay, so formula for edge length A is equal to 2R. Okay. A is equal to 2R. Okay. What is A here? Edge length. Okay. So, what is R? Radius. Radius of cation plus radius of anion. And here, radius of cation is 1 picometer and radius of anion is 2 picometers. So, we can write this as 2 into R plus plus R minus. Okay. So, 2 into 1 plus 2. Okay. So, 2 into 3, that is equal to 6 picometers. Okay. Then, from edge length, we can calculate the volume. Okay. So, volume is A cube. Okay. So, A cube is equal to volume. A cube is equal to, what is A here? Edge length value 6. So, 6 cube. So, 6 cube means 216 picometer cube. Okay. So, this one 216 picometer cube. Next, in a cubic closed packed structure of mixed oxide, the oxide ions are in CCP arrangement. 1/6 of tetrahedral voids are occupied by cations A and half of octahedral voids are occupied by cation B. Then what is the formula of oxide? Okay. So here, cubic closed packed structure of mixed oxide is there and all the oxide ions are in CCP arrangement. CCP arrangement means FCC arrangement. So it contains two types of ions. Okay. So 8 corner points and 6 face centered points. So CCP arrangement contains 8 corner points and 6 face centered points. So all the CCP arrangement that is occupied by oxide ion. So oxide, oxygen. Okay. So number of oxide ions. So that is equal to, so 8 into 1/8. Why? Because oxide ions are in CCP arrangement. CCP arrangement means we have to calculate all the corner points and also face centered points. So 8 into 1/8. So that is equal to 1. Okay. 1 corner point. And face centered point 6. So 6 into half. So 3 face centered points. So oxygen atoms are 1 plus 3. So 4. Oxygens are 4. Then coming to A cations. Tetrahedral voids are occupied by cations A. Okay. So here number of atoms are 4. Okay. So all the atoms are present in CCP manner. So number of atoms are 4. So tetrahedral voids are always double than the number of atoms. So tetrahedral voids, that is equal to 8. Why? Because atoms are 4 and tetrahedral voids are double than the atoms. That's why 8. Okay. So 1/6 of the tetrahedral voids are occupied by cations. Okay. So 1/6 into 8 means 4/3. Okay. So A is equal to 4/3. A ions is equal to 4/3. Next coming to B. Octahedral voids are occupied by cations, that is only half of octahedral voids. You know that octahedral voids is equal to number of atoms. That's why 4. So B is equal to 4 into half. So B is equal to 4 into half. Only why? Because only half of the octahedral voids are occupied by B ions. Okay. So that's why 2. Okay. So now A 4 by 3, B 2, O 4. Okay. So this is the formula. But here this formula is not given. Okay. So that's why we had to multiply this one with 3. Okay. So with that we get A2 B3 O6. So this is the